Today I'm going to show you how we are doing the density practice worksheet that you were assigned over the weekend. So I'm just going to go through them. If you have any questions, please feel free to reach out to me. Teams is the best place, obviously. So question number 1 says, a student measures the mass of an 8 cubic centimeter block of brown sugar to be 12.9 grams. What is the density of the brown sugar? For almost all of these equations, we're going to use density is equal to mass divided by volume. It may be rearranged such that mass is equal to density times volume, or volume is equal to mass divided by density. For number 1, we're going to stick with the first equation. Density is equal to mass divided by volume. Our mass is given to be 12.9 grams, so we'll substitute that in for mass. Our volume is 8 cubic centimeters. And when we divide 12.9 by 8, we are going to get 1.6125 grams per cubic centimeter. The question didn't ask us to find any particular unit of density, so we're going to use the units that were given to us, grams divided by cubic centimeters, and that is going to be what our answer is going to be in. Question number 2, very similarly, wants to know the density of oil, so we're going to again use density is equal to mass divided by volume. In this case, we have 43.5 grams of cooking oil that we're going to divide by its volume of 50 milliliters. If you take 43.5 divided by 50, you will get 0.87 grams per milliliter. Number 3 changes it up a little bit and asks us to find the mass. So we're going to use the rearranged equation. Mass is equal to density times volume. The density of our liquid is 2.5 grams per milliliter. We're going to multiply that by a volume of 15 milliliters. Now the volumes are going to cancel out, and we're going to be left with 2.5 times 15, and that is going to be 37.5, and our answer is going to be in grams because all of the milliliters canceled one another out. Number 4 is the last of the straightforward problems. It's asking us for the volume of a liquid given a density and a mass. So the equation that we're going to use is volume is equal to mass divided by density. The mass that we were given is 65 grams. The density of the liquid is 5.45 grams per milliliter. Grams are going to cancel one another out. The milliliters are going to come to the top, and that is going to be our unit for our answer. We need to divide 65 by 5.45, and we get 11.93 milliliters. The next problem requires a little bit more information than is given. So it says a machine shop worker records the mass of an aluminum cube as 176 grams. If one side of the cube measures 4 centimeters, what is the density of the volume? So we're going to use density is equal to mass divided by volume, and we're given a mass of 176 grams, but we don't know what the volume is. However, we're told that it is a cube that measures 4 centimeters on a side. So if we have a cube that is 4 centimeters on a side, it's going to look something like this. And it's going to be 4 by 4 by 4. In order to find the volume of a cube, the equation for that is multiplying each of the 3 sides together. What that looks like in our equation is mass divided by the length of the sides raised to the 3rd power. If we substitute our numbers in, we have 176 grams divided by 4 centimeters cubed. This gives us 176 grams divided by 64 cubic centimeters. And when we take 176 grams divided by 64, we get 2.75 grams per cubic centimeter for our answer. If you're unsure of the volumes of different shapes, they can be found in the back of your school agendas, also on the internet. Number 6, we have a teacher that is doing a demonstration, and it says that the cork displaces 23.5 milliliters of water. What that means is if you have something like a graduated cylinder, and you have, say, 50 milliliters of water in it, and then to that graduated cylinder you add an item, it will raise the water level. Let's say in this case it raises it to 73.5 milliliters. You can find the volume of the object by taking the volume with the object in it of the graduated cylinder and subtracting the original volume of the fluid. Okay, that is what displaces 23.5 milliliters of water means in this case. So that is the volume of the object that we're looking at. If we're trying to find the density of this rock, we're going to use density is equal to mass divided by volume. The mass we're given is 23.5. I'm sorry, that is the density. No. The mass is given as 5.7 grams, and the volume is 23.5 milliliters. To find the density, we're going to divide 5.7 by 23.5, and we're going to get 0.24 grams per milliliter. Number 7, a carver begins work on the following block of granite that has a mass, not weighs, 2,700 grams. What is the density of the granite? So again, density is equal to mass divided by volume. In this case, we have the volume. We do not have the volume, but we have the measurements of a rectangular prism. So if we take the mass and divide it by the equation to find the volume of a rectangular prism, that's length times width times height of the prism. Our mass is 2,700 grams. Our length is 20 centimeters. Our width is 5 centimeters. Our height is 10 centimeters. If we take 2,700 divided by 20 times 5 times 10, again, don't forget, I don't need parentheses here, but when you type that into your calculator, you will need them. You will get 2.7 grams And centimeter times centimeter times centimeter is per centimeter cubed. So this block of granite has a density of 2.7 grams per cubic centimeter. Number 8 says a piece of PVC pipe displaces 60 milliliters of water. Okay, so this is going to be very similar to number 6, because it says the pipe has a mass of 78 grams. What is the density of the PVC? So density is equal to mass times volume. Once again, the mass is 78 grams. The volume is 60 milliliters. 78 divided by 60 is going to give us a density of 1.3 grams per milliliter. And for the last problem on the page, we're finding the density of magnesium, of particularly magnesium flare, using density is equal to mass divided by volume. Our mass is 1,300 grams, and the volume that we're using is 743 cubic centimeters. So our answer is going to be in grams per cubic centimeter, and 1,300 divided by 743 is going to give us 1.75 grams per cubic centimeter. Moving on to page 2. A graduated cylinder has a mass of 50 grams when emptied. When 30 milliliters of water is added, the graduated cylinder has a mass of 120 grams. If a rock is added to the graduated cylinder, the water level rises to 75 milliliters, and the total mass is now 250 grams. What is the density of the rock? So using the equation density is equal to mass divided by volume, we want to find the mass of the rock from the given information and the volume of the rock from the given information. So to find the mass of the rock, we're going to have to take the total mass and subtract from it the mass of the water plus the cylinder. To find the volume of the rock, we're going to have to take the total volume and subtract from it the volume of the water. So the total mass that we're given for this problem is 250 grams. The mass of the water and the cylinder together is 120 grams. We're going to divide that by the total volume, which is 75 milliliters, and we're going to subtract from the total volume the volume of the water, which is 30 milliliters. This gives us 130 grams on the top divided by 45 milliliters on the bottom. 130 divided by 45 gives you 2.89 grams per milliliter. Number 11, we're asked to find the density of the 3 unknown fluids and draw them in the beaker as they would line up. What that means is the ones with the higher density are going to be at the bottom, and the lower density ones are going to be towards the top. Just like oil and why it floats on water. And so for fluid A, we're going to have its mass, 2,060 grams, divided by 2,000 milliliters. 2,060 divided by 2,000 is going to give you 1.03 grams per milliliter. The density of fluid B is going to be 672 grams divided by 850 milliliters, which is 0.79 grams per milliliter. Lastly, the density for fluid C is going to be 990 grams divided by 1100 milliliters, which is 0.9 grams per milliliter. So in the beaker, the most dense is at the bottom, that is A, the middle is fluid C, and the top is going to be fluid B. Now, the other thing that we have to look at is fluid A says that there are 2,000 milliliters of it. It's going to take up more space than the other two. Fluid C is going to take up about half as much space as fluid A, and fluid B is going to take up less than half. So, something along those lines. And lastly, for number 12, yes, last one, number 12, we need to use the given information to figure out what the different materials that these objects are made out of. And for all of them, we're going to use density is equal to mass divided by volume, with some slight variations for the ring and the block. So for the first two, our density is going to be the mass of the coin, 26.76 grams, divided by its volume of 3, this should be cubic centimeters. So our density is going to be in grams per cubic centimeter. 26.76 divided by 3 is going to give you 8.92 grams per cubic centimeter, which, according to the chart, is the density of copper. The one that might be a diamond is very similar because you are just taking its density, or finding its density by taking its mass of 5.28 grams divided by 2 centimeters squared for its volume. Sorry, 2 centimeters cubed for its volume. And 5.28 divided by 2 is going to give you 2.64 grams per cubic centimeter, and 2.64 is quartz. Moving on, we found a ring also, and that ring has a mass of 107 grams, and we're told that when we put it in a cylinder of water, the water went from 10 milliliters to 15 milliliters, meaning the volume of the ring is 5 milliliters. If we take 107 and divide it by 5, we will get 21.4 grams per milliliter, which, if you recall to the notes we did last week, milliliters, cubic centimeters, and cc's are all the same. So this is 21.4 grams per milliliter is the same as the 21.4 grams per cubic centimeter that the chart is given in. So 21.4 grams per cubic centimeter is made of platinum. And lastly, a block that works as a paperweight on your desk. We're going to find the density by taking the mass divided by the volume, except for the volume for this one is going to be the volume of a rectangular prism. So the mass divided by the length times the width times the height. The mass in this case is 184.32 grams. We're going to divide that by 3 centimeters times 4 centimeters times 6 centimeters. Again, when you put it in your calculator, you will need parentheses. So 184.32 divided by 3 times 4 times 6 gives you 2.56. Sorry, I'm running out of room here. 2.56 grams per cubic centimeter, which is marble. Like I said, if you have any questions on this, please feel free to reach out to me on Teams or email. I hope it helped.